Hello everyone, this is the section number 4 of our chapter organizing data that is distribution shapes. Today we are going to learn about distribution shapes. Okay, let's begin with the definitions. The distribution of a dataset. The distribution of a dataset is a table, graph, or a formula that provides the values of the observations and how often they occur. That is the basic definition of the distribution of a dataset. It's a table, graph, or formula that provides the values of the observations and how often they occur. Okay. If you can remember from the previous sections, this is the relative frequency distribution for height variable with the approximating smooth curve for distribution of height. The curve is bell-shaped. As you can see, the relative frequency is in the vertical axis and the height is in the horizontal axis, and these are the bars with respect to each relative frequency for each interval, and this is the smooth curve of the relative frequency, and it's bell-shaped. There are several kinds of shapes that you should be familiar with when you are dealing with different types of variables. This slide will show you the examples of several kinds of shapes as follows. The first one is a unimodal. It shapes like this. I think it's somewhat skewed shaped, and it's called as a unimodal. The second one is a bimodal. Okay, it's a little bit curvy than the unimodal. And the next we have the multimodal. Again, it has more spikes than bimodal and unimodal. We call it as the multimodal shape. And the fourth one is a bell-shaped curve. If you see a curve like this somewhere, it's bell-shaped for a graph. Okay, and the fifth one is a triangular. This is the triangular shape. It's very easy to remember, right? You already know what triangle is. The last one we can call it as uniform, or as well as it's rectangle, because its shape, it's the rectangular shape curve. Either it's uniform or we can call it as a rectangular shaped curve. And there are three other shapes as well that we need to consider when we are dealing with graphs. There are generic skewed distributions. Those are called right skewed and left skewed. For right skewed, the skewness is in the right side, and most of the data are in the left side. And for left skewed, the skewed part is in the left side, and most of the data are in the right side. That's how we identify the right skewed graphs and the left skewed graphs. And the next one is the reverse J-shaped distribution. That's very easy to identify. It's like a J. Yeah. It's somewhat similar to J, but it's not a J. So it's like this. It has a very gradual steep. Yeah, with a curve. As you can see in this slide, the relative frequency histograms for household size in US were plotted with their smooth curves. Well, it's smooth curve. This one seems like a right skewed distribution because most of the data are in the left side of the distribution, and there are some skewed data points at the right side, so we can call it as a right skewed distribution. You should have the ability to identify the curve by looking at the shape of it. If there is a relative frequency, if there is a graph with relative frequency, you should have the ability to identify which shape it belongs to. Okay, and now let's move on to some definitions. Population and sample data. Population data are the data that the values of a variable for the entire population. Let's say the students who are in the grade 6 for this entire school, for an entire school. That's what we call as a population, the values of a variables for the entire population. Okay, and the sample data, the values of a variable for a sample of the population. Let's say that we are taking a sample from that 6th grade students. We're taking a sample of 10 from out of 100 6th grade students. So that's we called as sample data, the values of a variable for a sample of the population. We are obtaining the sample from the population. Actually, we are not dealing with population data for calculations. Instead, we are dealing with sample data. So that's very easy to handle because the number of data are low than the population data, and there are some inferences that we can get from sample data which represent the population data. And the next definition is population and sample distribution of a variable. The distribution of a population data is called the population distribution, or the distribution of variables. And the distribution that we derive from the sample is called the sample distribution. The distribution of sample data is called the sample distribution. Okay, those are the two definitions of population and sample distribution. And in this slide, you can see the population distribution and the distributions of 6 samples drawn from the population. Each of these samples are different from each other because each of these samples drawn in different way. So there are 6 samples, and these samples have no connection with each other. The only connection is that they are brought from the same population. Each of these samples are different and they have similar distributional shapes, as I guess. Like all of them have the skewed shape, except for the second sample graph. All the other graphs have the right skewed shape, right? As a key fact for the calculations, for a simple random sample, the sample distribution approximates the population distribution. That is the distribution of a variable under consideration. The larger the sample size, the better the approximation tend to be. That is, we can take a sample distribution as a representation of the population distribution. When we increase the sample size, the approximation for the sample, from the sample to the population, will get better and better. That is the main idea of the approximation of a sample distribution to population distribution. Okay, that's all for this section, and see you guys in the next chapter. Thank you.